Okay, so here we have the notes for 6.5, inequalities in one triangle. Hopefully you went through the exploration guided in the announcement. And so some of this will just be as a repeat of what you hopefully found in your discussions with your group. Um, First, you explore the relationships between the sides and the angles of a triangle. And that's what this is saying is whichever side is longer, the angle across from that will be larger than the other. So 8 is our longest side compared to this one. So angle C must be greater than angle A. And if you just kind of think about that with a within one triangle, it kind of makes sense. Over here is pretty much the converse of it. Now we're given the angles. Wherever the largest angle is, the side across from that will be the larger side. So 50 is bigger than 30. So the side across from the 50, BC, must be greater than the side across from the 30, which is AB. You'll see that right here. All right. Now you're going to go through a couple examples, which are in your notes. Just push pause, answer them with your group, come back to get the answer. So push pause. All right, here are your answers. One part we had to do was find this third angle. So I took 180 and I subtracted um, the angles given from there. And then again, where's the smallest angle? This is the smallest angle. So across from that is the smallest side. Whereas the medium angle, that's right here. So across from that is the middle side. The largest angle is here. So across from that is the largest side. Right over here, two more examples following those same two ideas. Please push pause and work through those with your group. Right, you can see the angles here. I was looking for the smallest first, so I found the smallest side and went across from there to get the smallest angle. Found the medium side, went across from there to get the medium angle. And the largest side went across from there to get the largest angle. And the same idea here, smallest angle, so go across for smallest side, medium angle to go to medium side, largest angle, largest side. Now the next part is the triangle inequality theorem. Again, you were told to look through this in the announcements, in that exploration in the announcements. You can see it here. I just want to show you why that kind of makes sense too if you were struggling with why that works. Okay, so here I have three lengths of sides. Over here I have F and H. Those are these two sides right here. And down here is just a repeat. That's this length here. So don't really worry about the top. Just focus on these two down here. So if I have, you can see this makes a triangle. And the sum of those two sides is greater than the third side. And that'll hold true for a lot of different situations. But let's see why. Let's make these less than that. So here's the sum. See the sum? That's less than the third side, this side down here. Now, if I brought that down, and it was about 2.6, I believe. And I brought this one about 1.75. Can you see when they are less than the third side, even if you laid those two sides right flat on top of this third segment, they're not going to have enough to reach across. So if the sum of them isn't even equal to that, they're not going to be able to reach across. You can't make a triangle. They're not going to get there. Now, let's say they were equal to it. So I will try my best with that. All right, so I'm pretty close. GeoGebra rounds to a long decimal place. If they're equal to it, the sum is equal to it. Now it's just one segment on top of another. If they're not greater, I'm just basically putting a line on top of another. There's not enough space to kind of lift it up. If you think of a tent, maybe one of the triangle type tents, you need a little bit more so that the triangle can move up, that there'd be enough space that I could move these points up. And as soon as I get that, now they have to be greater than the third side. So that's what we're looking at here. Any two sides have to be greater than the third side. If they're less than, remember now they're not going to meet, they're not going to even connect to be, they'll be two separate ones. And if they're equal to, they're just going to lay right on top of the green line. So here's some problems here. You have your notes. I apologize, this watermark is here. So again, I'd like you to push pause and answer these in your group. So please push pause now. All right, over here, most of you hopefully did well with the third side has to be less than 23. Okay, so the sum of two sides must be greater than the third side. So this first line here, that's where that comes from. But we also have to remember 14 has to be then the bigger side. So I wrote the third side also has to be greater than 5. If it was 5, then 9, this is the 9 right here, plus 5 would equal 14. I would have that situation where the two sides just kind of lay on top of the third side. They can't lift up to make a triangle. If you pick anything less than 5, okay, 9 plus that other one, they're not even going to reach each other. So the third side has to be greater than 5. So there are two restrictions. It has to be less than 23, okay? And it has to be greater than 5. Over here is the same, and the 5, if you didn't see, the 5 comes from 14 minus 9. That's where the 5 came from. Okay, so if I made the third side, let's say, was 6, that would meet the requirements that two sides are greater than the third side. In the second one, same idea. The third side has to be less than 32. The sum of two sides must be greater than the third, so I added the two sides together. This third side has to be greater than 8. Again, 12 plus 8 would give me 20. That would give me enough that they kind of laid on across, but if I was any number greater than 8, now I have enough room to kind of move the triangle up. All right, then down here we checked. So I found the largest side, and I need to make sure these two are greater than that third side. So 9 plus 4 is 13. 13 is greater than 10. That works out well. So it's not just the first two numbers. I'm always leaving the largest number and seeing if the other two can be greater than that. In this one, 8 plus 9 is 17. Okay, so again, I connect the 8, I connect the 9. It's only 17. It can't even reach across the 18. So that one can't be a triangle. And over here, again, 5, 7, 12. 5 plus 7 is 12. It's not greater than 12. I need the two sides to be greater than the third side. So no, this cannot be a triangle either. All right. So you can talk about your answers in your group. I'm going to stop the recording now and you can go back to the announcement.